All right, for those of you that have not been in here before, remember, like I said, very beginning, day one, you're not going to see very much stuff on campus. You're going to have, by the end of the semester, 11 or 12 of those weekly quizzes, and you'll have 0, 1, 2, 3, 4, 6, 7, 10. You'll have 8. It'll say unit blah daily work. So by the end of the course, there's going to only be 21 total things in the gradebook. Okay, it's not a lot because you know what you're doing. You know if you're doing okay or not. When we do these daily checks, you know if you get it or not. I don't want to sit and push papers. I don't want to sit and be grading every tiny little thing and waste my time on that when I could help kids. I want to spend whatever time I have in this building helping students. Okay? So when it comes time for that quiz, do not come in and say, did you grade it yet? 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 Do not watch campus like a hawk. Y'all, when I grade them, I'll put them in and I send out a reminder to everyone, and it's got a cute little bar graph to show you how everyone did. Because we all know that, especially if you're in pre-calc, you like to compare yourself against your peers. Okay? So, just wait. And at some point, you'll get a text and they'll have that cute little bar graph, and you'll know the grades are in and you'll know how everyone did. Okay? It might be in 2 days after the quiz, it might be in 3 weeks after the quiz. It all depends on what happens at home. I can't bring work home. Like, I can't do work at home. My responsibilities at home preclude the ability to do work at home. Okay? So I get it done whenever I get it done. I say no due dates for you. I try to be flexible because I know life happens. I just ask that you also offer that same courtesy. I will get it done as soon as I actually can get it done. I should be more on top of things this semester because I've got smaller classes, and instead of having 4 different classes, I'm down to 2 classes, 2 sections each. So it just reduces the workload a lot. So I should be more on top of it. And Baby Bear's got his tubes now, so hopefully we won't be dealing with 5 friggin' double ear infections. No daily check because we had a quiz yesterday. No assignment yesterday because we had quiz. So we just jumped straight into it. 06, here we go. When was the last time you saw these? ACT. Yeah. For those who were not in my Algebra 2, I know I didn't get to them, did they show you systems by matrix?
Yeah, kind of. Not a ton.
Okay. I just kind of did one real quick that way to show kids, oh, hey, look, they're the same numbers, just all the letters are gone. And some kids seemed interested, some didn't. We didn't have enough time to go through it. Now I ask the question that I've been asking for 8 years, and I'm pretty sure I know the answer. Did you use these in geometry? Because that's why you learn them in Algebra 1, is to do transformations in geometry with these, because it makes life so much easier. So, they're still not doing that. All right. Start with basic vocabulary. Yes, this is a matrix. A matrix is a ordered arrangement of data. And it's going to be row by column is going to be the dimensions of the matrix. It's always row by column. How do you know the difference for those of you who are challenged and don't know left and right without holding up your fingers? Oh man, did we just shots fired? How do I know the difference between rows and columns, right? Think of like the Colosseum, Roman architecture, Greek architecture. They always have columns. Columns are up and down. Okay? So row by column is how I state this. I would say this is matrix A, and I would call it a 3 by 4 matrix. Because it's got 3 rows, 4 columns. That's also how I'm going to label all of the elements, the single data point. The elements of those are going to be labeled as a subscript of whatever the matrix is. So if this is matrix A, this guy right here, see how it's in row 2, column 1? I'll call it element A sub 2, 1. Big A, name of matrix. Little a's, elements of matrix. And the subscript on it tells me the row and column number. You have seen sequences in series, okay? That is not to the 21st. That's a subscript. Like y'all remember doing these? A sub n is a sub n minus 1 plus d. Remember that kind of stuff? Okay. This does not mean a times n. It doesn't mean a to the nth power. It means the nth version of a. It's telling you which one in order. You've seen this before. Y'all remember this? Right? Those didn't mean y squared. It meant the second y. So when I put a subscript on it like this, I'm not saying the 20 a to the 21st. I'm saying the row 2, column 1 element of a. So what's this guy? Row 3, column 2, I'm going to call that element a sub 32. Okay, easy peasy. What?
Why is there 12? That's such a weird number.
12? I had to negotiate with them.
I only get 12.
Because we started with only 10 kids in the class.
Yeah.
And then the only 2 to drop this semester happened to be from that class, so now we're down to a class of 8.
That was just an awkward number. I didn't know that.
Some kids would love it, some kids would hate it. Depends how much they like talking. Okay, down below that we have row and column matrix. Obviously a row matrix, only a row, so it's a 1 by something. A column matrix is a row by 1. So they're just 1 for row or column. Square matrix, your rows and columns are the same. And a zero matrix, if you can't figure that out, I don't know why you're still here. So, stating the dimensions of it. Down at the bottom, A and B. Tell me the dimensions and state what is element A sub, what's that, 13, for this matrix down here. Just making sure we know the vocabulary. Remember, row by column, and that goes also for the subscript on what element we're talking about. Those of you that came out of a different Algebra 2, I know in my class we were struggling for time. We had to fill in a lot of gaps. I had kids, there were 3 kids in my Algebra 2 who literally could not plot a coordinate. Like they could not graph a line when they came in. We had to fill a lot of gaps. Okay, there were a few kids that didn't make it out of there, and there were a few kids that made it by the skin of their teeth because they worked with me every day after school. I had to fill a lot of gaps. Sometimes that just happens. Okay, because of that, my Algebra 2 didn't get to a lot of stuff that I wanted to or that we should have. Did the other classes get to multiplying matrices? Okay, all right. So might have seen a system by matrix, but didn't really practice it. Definitely didn't multiply them.
I remember explicitly
Okay, I'm checking because I want to know when we have 4 teachers doing Algebra 2, who knows what you got coming into pre-calc, okay? Especially after last semester, that last week where we lost like 4 days in a row, that hurt. We had to chop up logs because of that. What are the dimensions on this guy? 2 by 3, row by column. And element A sub 13 would be row 1, column 3, or number negative 18. Yep. Okay. Add and subtract matrices. They're very, very simple. So long as the dimensions match, I am able to add and subtract corresponding elements. So if I say matrix A plus matrix B, I'm literally taking element 1, 1 plus element 1, 1. I'm taking element 1, 2 plus element 1, 2. Finish it off. Show me no basic arithmetic. And it only works if the dimensions match.
When you say like show me no basic arithmetic, I get so scared.
I have a whole board to prove that sometimes I don't. Okay? It's okay to make mistakes. B minus C. Do you understand, just looking at that, why they have to be the same? I'm saying B minus C is 12 minus 2, is 6 minus 9, is negative 7 minus, damn. Like, there's nothing to do, right? Because it doesn't have another element. And you say, well, can I just use 2 again? No. You already used that. Stop it. Okay? So for this, I would just say it doesn't exist. Okay? I can't do it. It's not possible to even start the problem. You'll also find as we get into matrices later that matrices are they're not closed under the full set of operations that normal addition and multiplication are. Matrix A times matrix B is not equal to B times A. In fact, they might even be in different sizes. Okay? So that's later, but scalar, you seriously didn't do any of this with geometry. God. Okay. Well, you did this back in algebra like 1.
Yeah, I remember seeing it in geometry though.
The reason we introduced this in algebra 1 is to help you with transformations. I'll show you in a second. But scalar multiplication is literally just super distribution. I am taking this matrix and I'm dilating it by a factor of 3. So I'd say negative 18, negative 9, 21, 36, negative 45. So show me you know basic distribution. Oh, everyone's does them. It just takes longer to type in the matrix than it does to just do this. Like mental math is faster than typing the matrix. Yes, there are matrices in every one of your calculators. I'm not sure about the Casios. I think it's on there. I just got to find it. But all of the TI-83s and 4s, definitely. So just Disturbert. Negative 8, 36, negative 28, negative 12, 44, negative 16. And you notice it is still a 3 by 2. All right. Here's why you were shown that back in Algebra 1. Do you remember getting a figure like this, and I would say triangle ABC given? I would like you to translate 3 units down and 4 units left. I would like you to reflect across the x-axis. I would like you to dilate by a factor of 2. You remember doing this?
I remember doing that. Yes.
Where you would have to take all those coordinates and then you would move it and you'd say A prime, B prime, C prime. And then you would reflect it, A double prime, B double prime, C double prime. And then you'd keep going and going and going. Did you do rotations?
Yeah.
Did you do rotations around a point besides the center?
Yes.
Where I would say, I want you to rotate around the point -2, 5.
Yeah. And just everything matrix.
A matrix is just a organization of data.
I could totally guess how you would.
So triangle ABC would be X's, Y's, A, B, C. I would just write this is coordinate 2, 3, 6, 1, 7, 5. If I say translate it 3 down and 4 left, that means 3 away from all of those. 0, -2, 2. 4 left, subtract 4 from all of those. -2, 2, 3. Reflect across the x-axis. Okay, negate all of these. Dilate it by factor of 2. Multiply everything by scalar 2. There you go. That's where ABC triple prime is. Done.
I'm kind of bored.
Right?
You know how much time that could have saved me on the ACT? I had like 5 questions like that.
Right? I've been begging them to do this for 8 years, and they won't. When I did transformations as a geometry teacher, that entire unit took us about 3 days because of this. It's super fast. Say you wanted to do something, rotate around a non-standard point. Like say my triangle is up here and I wanted to rotate around this point. Easy peasy. I'll perform this translation for the whole figure. Then I'll do my rotation and then I'll put it back. So I add or subtract values, do the rotation thing, it's like flip X and Y, negate X's kind of thing. And then I will undo the translation. Ta-da, 3 steps. You're done in about 30 seconds. That's why you learn this in Algebra 1. It is considered standard curriculum to do transformations by matrix. And they just don't like that here. So, multi-step operations. The way that most textbooks would like us to do this is overkill. If I say 4p plus q and then I give you these, they literally want you to say 4, womp, and write this, then to do this, and then answer. Could you mental math your way through that? Pretty easy, right? Take p plus q, whatever that is, times 4. Straight to answer. Go! If I'm taking 4 times the quantity p plus q, take p plus q, whatever the answer is, times 4. Okay, shorthand it, make it easier. So 3 plus a -4 is -1 times 4. Okay. You can write it out if you need to. You can count on your fingers if you need to. I'm just saying, if you can work smarter, not harder, go for it. 52, 7, 20, 5, negative 2, negative 8, 5, negative 5, negative 20, 4, negative 6, negative 10, negative. I mental math before lunch. Check me before I wreck me. It's dangerous to mental math before lunch. I thought that was going to be a correction. Like, I think the negative 20 is supposed to be positive. No, it was, I think I want nap time. Right? It's funny when you're a little kid and you have rest time in the middle of the day, you just rebel against it. Like, no! You get older, you're like, God, I want a nap.
I almost every afternoon I take like 3-hour naps.
Yeah.
But that's because I was like really flexible.
Okay.
Oh my gosh, these are all divisible by 4. That's so nice. How pleasant.
Okay.
I wish it was
A matrix equation, again, they want us to actually plug those matrices in here. They say 4x minus, and they want the entire matrix equals the entire matrix. They want you to write plus the entire matrix plus the entire matrix. Getting 4x is the entire matrix. Then they want you to divide both sides by 4 or multiply by 1/4 because division is a lie, and get x is 1/4 by the matrix, which is answer. Do you really want to write all those matrices out?
No.
Instead, I'm going to use that multiple operation thing right above this to say, how about I just solve for x over here? Add b, add b. 4x is a plus b. So x is 1/4 a plus b. So if I solve the equation for x off to the side, now it just tells me my multiple operations to do just like the one above it. Now it just says take a plus b, whatever that is, times 1/4. So I would take negative 9 plus 5 is negative 4 times 1/4. I would take 15 minus 7 is a 8 times 1/4. 4 plus an 8 is 12 times 1/4. 2 plus 14 is 16 times 1/4. Negative 10 plus 10 times 1/4. 0. Negative 5 plus a negative 3 is negative 8 times 1/4. And there you go. I would much, much rather do the multi-operation form instead of writing the matrices out like that. Now, yes, you can input these in your calculators. Do you know where? In matrix, right? Second, matrix. The first thing that you're going to do is you would edit a matrix. You would state what its dimensions are. You would fill in everything. And then you can't keep typing or else it's going to type inside the matrix. You have to exit the matrix before you are able to do things with the matrix. Okay, so whenever you're done inputting stuff, you have to second quit. You'd come back here, and now let's say I wanted 1/4 of matrix A plus matrix B. You literally just do that, 1/4. Frank? Oh, alpha. Okay, Frank, you're good. That was my fault. I would do 1/4 of, and then second matrix, and I would just say, this is the thing I want. plus second matrix. This is the thing I want. B, I close it. Now, right now, it's going to tell me to screw off because I don't have anything in B. Okay, so it's an undefined set. But just letting you know, you can input all this stuff in there. That allows you to do operations with them. If you have not seen multiplication of matrices, just dump them in there. It takes longer than the mental math part. We just haven't seen that yet. The multiplication of matrices we will do later in the class. But for now, I just wanted to show you, you can put stuff into your calculator.
You can
Okay.
take like a different dimension of matrices and make them like other dimensions, right?
Now you're talking discrete math, and that is one of the things that we have actually been cutting out of this class.
Oh, I remember seeing it in like geometry.
Shouldn't have been.
I remember seeing something. It might have been one of those things that like taking Greenwald's class, he was like, "Hey, fun fact, look at math thing," and
I mean, to be
that
fair.
a lot.
Oh yeah.
Here's some weird college math fact that they don't teach you because it's like gonna help you so much that you won't learn how to do it the other way. And then it wouldn't be a part of like our actual stuff. And then I know that they missed by forget it.
10. So 10. So what if I say 5 1 5 1 1 5? Stuff like that. You ever heard of modulus or different bases?
Oh yeah. What base is that in there?
Mod 5. In mod 5, that would assume that we didn't have 10 fingers and our number-based system was based on 5. So I go 0, 1, 2, 3, 4, 10. 11, 12, 13, 14, 20. Blah, 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 40. 41, 42, 43, 44, 100. Because every time you hit a group of 5, it's the new place value. Oh. More progressive schools will actually use that to teach place value in elementary school. It's pretty cool. So, use of a matrix equation is just a way to organize data, especially if I see tables. Do you see now how that table is just a matrix? They just take away all the stuff on the outside. And we understand that the rows are the classes and the columns are the different categories we're talking about. I just want you to read the problem so you understand how old this textbook was.
Some people still have minutes.
The number of minutes on your phone, the number of pictures sent per week. Per week. I know there's some of you in here who were sending 20 in this class. Okay? Like, be honest, how many of you were snapping pictures on Be Real like 5 times per class?
You can only do one thing, right? I don't have Be Real, but.
Oh, there was a kid that had multiple accounts because I just wanted to keep doing it. But they just liked that the internet wanted to know what they were doing. Like,
Some people would totally love this.
So,
Like they'd read Orwell and be like, "Oh my gosh, this sounds so like cute."
Right. All right. Anyway, conversational tangent. Y'all, this just allows me to do scalar multiplication, and it's a way to organize our data. If you're interested in that, if the idea of putting things in boxes and sorting Legos is just your jam, discrete math, take it. You will love it. Okay? Like, if you are the kid who cannot just eat a handful of M&Ms, you sort them by color, and then, okay, now who's the kid who, when you sort them, do you put the same colors together, or do you do alternate color pairs, or do you do color sets? So you have to have a red,
I can't eat so many greens at the same time.
right? And this will start fights. This will start fights.
The way I assemble Lego sets Each bag at a time. I organize them by color and by size.
All right. I know. You start talking about how you eat your food, and people will straight up start fighting. So just chill. I'm just gonna say cross that page out, or cross that slide out. I don't worry about it. It's just you can use matrices for other things. There's no use of me spending another 10 minutes on that slide if y'all have never done it before, and there isn't too much application for it beyond discrete math. Okay.
Before we move on,
Yeah.
that was just like we're not doing that limit, right?
We aren't doing who what?
Because I was chilling on this and I didn't catch.
Like you actually can't.
Yeah, that's what I thought, right? It's
Yep.
just that.
Yep. Okay. Show of hands. Who had Algebra 2 last semester? Okay. No, that informs what we're about to do here. Those of you who had Algebra 2 last year, did you have it first semester or second?
First.
Second?
Second.
Second? First? Okay. The reason I say that is because last year, first semester, we got towards the end of the semester and I started talking to my class, and turns out they had never seen probability statistics at all, ever. They had never seen a box and whisker plot. They had never done probability. They have never done permutations and combinations. They had never seen it
But box and whisker is
because they had never seen it because they all had Algebra 1 during the Spring 20 shutdown. And as a result, when they were in Algebra 1, they just never saw this at all. We thought we were going to be able to just kind of turbo version, here's 2 days, okay, you remember this, and done. We had to cram in like a week and a half of stats within a few days. Second semester last year, you should be okay because by then we were sort of back on track. Well, last semester, which is most of you, we had to plug a whole bunch of Algebra 1 gaps. So most of our Algebra 2 classes did not get to prob stats. Okay? So I'm just going to, if you are one of the few that has actually seen this stuff, great. If not, I'm going to assume that everyone in the room just has no idea what this is. Okay? So, first up, basic and yeah, like prop stat stuff, this is on ACTs. Guaranteed.
Yeah, the box and whisker especially. I saw like 2, 3.
First up, basic vocabulary. An experiment is just where you have multiple trials. You record outcomes. And then you are going to do crap with data. Okay? An experiment is a controlled set of trials where you define what is a success versus a failure. And it can be something as simple as I'm going to roll a die 20 times and see how many times it comes up even. Okay? That would be an experiment. A sample space is all of your recorded data, all of your outcomes. Not the theoretical stuff, but I actually observed it and I wrote it down. Independent and dependent events. Ask a teenager to define independent versus dependent without the word depend. Go. Okay, and then we just start using synonyms, right? Literally, it's when one depends or relies or affects the other or not. Example of independent events would be outcome A does not affect outcome B. That would be like I roll a die and I flip a coin. What happens with the die does not affect what happens with the coin. They have nothing to do with each other. Yes, I know you can start to argue niche, narrow cases and semantics. Well, like, if the die came up right on its corner, then you know there's a Jedi in the room, so it's likely that the coin is going to be on its edge. Like, don't be that kid. Don't be that kid. Okay?
I just need to code a counter saying that.
Oh, yeah.
You're gonna get the points or what?
Yeah.
It's rich.
Now, okay, here's another example then. Independent events. The probability that I pick one of you at random and kick you out to the cabin right now. But you're allowed to come back in a half hour. And then I'm going to do it again. Well, I don't know. It's random. Doesn't that person have an equal opportunity of being chosen every time? Everyone in the room has an equal chance of being chosen. Dependent events, every 10 minutes, I'm going to pick someone at random and kick them out of the room, and they ain't allowed back. Now it's dependent because right now we got 1, 2, 3, what's that, 8, 11, 14, 15, 16 in the room right now, right? So if I've got 17, if I've got 17 in room right now, no, it's just we literally have, no, there's 16. Well, I'm not going to kick myself out. Okay. If there's 16, well, I mean, I've been on the verge of it for 3 years. If we have 16 people in the room and I kick the first person out, they got a 1 in 16 chance, right? But if they don't come back, what's the probability you get chosen as the second person? They don't come back. What's the chance you get chosen next? Okay, that's dependent events because every time there are less possibilities, there's more likelihood that one gets chosen. So when one affects the other or not. Yeah?
What was the definition for?
That was so random. I have a belly button. Like, right?
What was the definition of sample space?
That is your recorded outcomes. Okay. You have been doing these type of problems since elementary school. I want you to read and figure it out. Argue with your neighbors. Answer the questions, A and B.
Yeah, a super solid. Yeah, so there's 6 appetizers. A super. So that's 2, so it's 6 times 2 times 12.
Let's research. Wait. 1, 6, 7, 8, 20. 28. Wait, is it like
There is
I'm so confused. So it's 6 to 1. Well, I think that's a pretty good size. 28. You don't add.
6, 12, 8 plus the super salad.
I don't care.
We don't. 6 times 12 times 12.
Yeah.
So instead, I have no idea.
I
know how it works, Kingdom. I just don't know how to do it. I don't know that.
3 times 1.
There's over 10 the likelihood of 1,152, right? Right, guys? We all got that?
Wait, is the 5 is like 5 exclamation points with after
I just tied them all together.
What are some other good entrees?
No.
What are some other?
chili.
One down.
Ooh, chili. Chili's a side.
No, it's not.
Chili's a side. It's offered as a side dish, a cup at Dickey's. Fine. I'll put it. You are so chaotic. You know what? Here, turkey leg.
I thought that said Twinkie. What does it say? Turkey leg? These are I can't see. Okay. And I was like, oh, I'm
Okay. Do y'all remember? You probably remember doing these back in elementary or middle school where you would have to list all of them out. Every time you have a new, like if I do burger, soup, and then fries, and then a cookie, that's different than burger, soup, fries, and apple pie. And you would have to list them all out, right? Every time you changed one option, it was a new combination. Do you remember? Hey, I know that there were some of us that were saying this, so some of us remembered. There's something called the fundamental counting principle, where you would have listed these out. It would have taken you and your class like a half hour. And after you got through all of it, then your teacher says, you know, you just multiply the categories together, right? Yes. The fundamental counting principle says you take how many options are in each category and you just multiply them together. So do that. What do you get? Okay. Now, there's a lot of kids who are just going to multiply those together because all they see is numbers. They don't even read the problem. They just see numbers and multiply them together, and then they forget, hey, soup or salad. Okay.
I'm gonna be honest, we couldn't have made it through 1,152 combinations.
Oh God, that would have taken forever.
Yeah.
Okay. For part B, I want you to think about that. If I'm multiplying how many options I have together, you're arranging what? 5 bestsellers on a display. So I've got 1, 2, 3, 4, 5 spaces. How many options do I have for the first spot?
5.
But I've taken a book out. These are now dependent events where I now have 4 options. And then I have 3, and then I have 2, and then I have 1. And you hopefully will remember that is 5 factorial. With the exclamation point is said factorial. It's not just 5. Okay? 5 factorial means you take 5 times every natural number below it. Okay? This is also one of the few ways that you can break your calculator. Factorials get so big so fast that factorials are one of the few ways you can cause an overflow error on modern calculators. Like, what's the highest that your calculator goes? How much memory does it have? This is like asking the math nerds how much horsepower you're running. Okay? How far does yours go? Can you go up to 100 factorial? Or does it say, nah, dude?
Let's find out.
Where's the limit on your calculator? If you don't know where that is, Under most calculators, it will be under a probability menu. On the 84s, it's under math and over to probability. Exclamation point is factorial. Additionally, because factorials are one of the more common functions to use in math, if I go alpha window, it's on that list. Alpha window is the most commonly used functions, just like alpha y equals is your fractions. Okay, so how high can you go? How high does your calculator go?
100 is not an option.
100 don't work. Okay. I want you to think of how big that gets, though.
Wait, how do I?
100 times 99 times 98 times 97 times 96 times 95.
We made it to 70.
So you got up to about 70 and then it quit?
I don't know how to do that.
No, math.
I
Math.
wasn't paying attention.
Can I borrow this?
72. Yeah. I don't. No, I like how you knew. I was like,
I'm just curious how high your calculator goes depending on its RAM space.
70 doesn't work.
Okay, so I'm hearing somewhere between 60 and 70 for the TI-84s. No way.
Yeah.
Noise.
Oh, man.
All right, insert sophomoric reference here. So, the reason I got to know factorials is because
Isn't there it's not called a factorial, but it's an exclamation point before the number, and then that's something.
come back for Calc 2.
We talked about it in math club, and it was something that the trig kids weren't getting, and I got it in
Okay.
geometry.
Permutations and combinations. Who's heard these words before? Who knows what they are? Okay.
I know what they are.
Permutations and combinations are when I want to find out how many options I have, whether order matters or order does not matter. Okay? Here's what I mean. If I look at this table, okay, and I want to say how many ways can I have these three sit at this table? Well, whether Owen's on this side or that side, he's still at the table, right? That would be a combination. Doesn't matter where he's sitting. But if I say the arrangement matters, because now if you're on that side, doesn't that change the dynamics of the table a little bit? Maybe you talk to one person more than another. Maybe you cheat off of one person. Maybe you always poke that person. Maybe you just don't shut up if you're near that person. Whatever it is, the arrangement mattered. That's a permutation versus a combination. Have you done that anywhere in your mathematical career? A permutation, it's written as NPR, also one of the few remaining mostly objective news outlets. Okay.
Oh my.
I say mostly. Okay. This is the number of choices. Permutation. And R is number chosen. I want you to see how big that gets in here. How many ways could I take 16 kids and arrange you in a line? Where if Lori is in front of Sammy versus Sammy's in front of Lori is a different option, right? Think of like your passwords. What if you just misspell your own password? Okay. Well, now that order in the letters changes it, right? So what I would do there is I'd say 16 permutation 16 because I'm putting all 16 of you in order. At the top of this page, it says if my N and R are the same, it's just 16 factorial. Okay? Because I have 16 options for first, that kid's in place. 15 options for second, that kid's in place, and on and on and on. What a permutation allows me to do is, well, all right. If I said 16 permutation 16, that would be 16 times 15 times 14 times 13 times 12, all the way down to 3 times 2 times 1, right? What if I said I want to only arrange 4 of you?
16 times 15 times 14 times 17.
Okay, so to get rid of that, when I say choose R, my R, if I'm only choosing 4 of you, means I'm going to take that, what is it, n factorial over n minus r factorial. If I'm only choosing 4 of you, then I need to get rid of all those other slots, right? So I divide it by 16 minus 4 is 12 times 11 times 10 times 9 times 8 times 3 times 2 times 1. And those all cancel. And that's what leaves this. Okay? That's why the formula looks that way when it says n factorial over n minus r factorial. In Algebra 1, you should have done these exactly like this manually. Okay? Usually in Algebra 1, you do these manually. And then you come up to Algebra 2, which it sounds like most of us didn't get this, and we say, nah, dude, there's a button for that. Find it. Where is the NPR button? Hmm? Burp, burp. No joke, that's what.
Is my code more advanced?
Yeah, math over to probability. Okay.
Oh, I see it. Wait, what's it called? NPR.
It's math. It's math.
Oh, probability. Depending on which percent you have. I found it.
Alpha window 7.
Okay. It's not often that I say listen to a brewer, but everyone calm down. I want you to listen to Shade. Say that again, sir.
Alpha window 7.
Because factorial and permutation and combination happen so often, it is in the shortcut menu on the TI-84s. Okay? So you can either math, probability, find it, or alpha window brings up the shortcut menu and you can use that. Now, keep in mind, depending on what calculator you're on, say I wanted to arrange 8 of you. I want to arrange 8 of you in line. I would say alpha window or go math over to probability. NPR, because I'm arranging, the order matters. I'd say I got 16 kids to choose from. I am arranging 8 of them and see how I just fill in the boxes. Okay, that's a lot of ways to arrange kids. On the TI-83s and a lot of the scientific calculators, you type 16, you hit the NPR button, then you hit 8 and equals. Like you have to type the number first, then hit the button, then hit your R. Okay? The big thing I want you to get out of that, I please write up here next to permutations. Order matters. Order matters for a permutation. In a permutation, think like passwords. For a password, whether I put the 5 or the 7 first matters. How many times have you just fat-fingered missed the password and now you got to retype it? And then you got to retype it. And then you got to, oh crap, now I'm locked out. right? The order matters. And they're going to have some arrangement word. Like they will say, I'm arranging them tallest to shortest. I'm arranging them least to greatest. I'm arranging them. I'm going to hand out jobs to everyone in the classroom, but the first person gets to choose theirs. The second person gets to choose theirs. Okay, now does it matter if you get chosen first or 15th? Y'all have been stuck with the really crappy job at the end because all the good stuff was taken, right? So order matters in permutations. And the example they give us is passwords. An alarm system requires a 7-digit code using digits 0 through 9. I can only use them once. That's important because if I could use them multiple times, well, if I got 1, 2, 3, 4, 5, 6, 7 options, or 7 characters, how many options do I have for the first one? How many digits are there to choose from? 10, remember 0 plus 1 through 9. If I was allowed to pick those same numbers again, how many options do I have for the second one? 10 again, 10 again. I would just say 10 to the 7th. But because it says only once, instead, I'm going to use my permutations. I have 10 things to choose from. The order matters. I am choosing 7 of them. And I'm just going to dump that in my calculator. Okay, 10 permutation 7. It's a big number. 10, 9, 8, 7, 20, 7, 40, 90. I ain't even doing it. Nope.
Yeah, I was gonna say you were despicable.
I was getting there, but I'm tired. What is big?
1648.
God, I feel like I'm on Price is Right. None of this is making sense. Someone say a number.
604,000.
Okay, because I heard 674, 218, $1, Bob. If a code is randomly generated, what's the probability the first 3 digits are odd? Okay, now is... I'm going to hit you with that dinosaur. Okay. Everything I've talked about up here so far, you should have gone through in Algebra 1. In Algebra 2, which it sounds like most of us didn't get this part, you would have been introduced to combinatorics. Combinatorics is where I start to put together all the different aspects of probability. You have the fundamental counting principle that says you multiply together categories. You have the definition of permutations and combinations where order does or does not matter. And probability itself, do you remember how to find probability? Probability, what is probability? The likelihood something happens, and specifically, probability is the number of successful trials over the number of total trials. So like, there are 16 kids in here. If I asked, what is the probability I choose a kid at random and they are wearing glasses? Well, I'd look around the room and say, how many glasses we got? I see 1, 2, 3. So I'd say 3 out of 16. Okay? That's basic probability. Combinatorics puts all that together. It says, for this problem, what's the probability the first 3 digits are odd? How many ways can I choose 3 odd digits in a row? Well, how many odds are there to choose from? 1, 3, 5, 7, 9. I have 5 to choose from. Does the order matter when I'm doing this password?
Yes.
Does the order of your password matter? Yeah. How many am I choosing? 3. So this is the category for odd. My first 3 digits are odd. How many digits do I have left to make the code? Remember, you can only use them once.
Yeah, we're going for the first 3, right? So it's 10, 9, 8.
I don't have 10 options. I just used 3 of my numbers.
Okay.
I have 7 options now because I just used up 3 of them. There are 7 numbers left to choose from. The order still matters because I'm making a password. And how many more numbers do I need to fill out my code of 7 digits? I need 4 more. Okay. Permutations allow me to shorthand instead of repeatedly writing things out. How many ways can I make 3 odd numbers in a row? Well, I got 5 of them. I'm going to choose 3. The order matters. How many ways can I fill out the next 4 digits of my password? I've got 7 left. I'm going to choose 4 of them. They can be odd or even, doesn't matter. This is category 1. Category 2. If I take this times this, I will get the total number of ways that I can generate this code. Right? How many entrees times how many sides? That's what this is. This is going to be a big number. But probability says number of successful trials divided by number of total trials. How many total ways can I make any code? This guy, right? Over 10 permutation 7. I can jam that whole thing in my calculator in one shot. I can take, what was it? Okay. I set up a fraction. And on the top, I'm going to say we're doing 5 permutation 3. Frank is kind of slow when he does that. Times permutation. Come on, Frank, hurry up. 7, choose 4. My denominator is how many ways is this total possible? Probability is number of successful trials over number of total trials. I'm saying there are 10 things and I am arranging 7 of them. Okay, that's what this says. This is number of ways to do odds. This is number of ways to fill in the rest of the code. I multiply them together to get the total number of ways I can make a code that's got odds in front. Specifically, my first 3 are odds. This is a number of total ways that I can make a code of 7 characters. I hit enter and it just tells me I have a 1 in 12 chance of making this happen. Yeah. When I hit alpha y equals, you ever look at the rest of the options? Option 4, F to D, fraction to decimal, swappy swappy. Additionally, if you go into math, the very first 2 options are change to fraction, change to decimal. Okay. I know this is a lot to throw at you because we're trying to shorthand what should have been a whole chapter of stuff that we didn't get. So I want you writing something down here. This is like ultimate cheater code. Probability is number of success over number total. Okay. Fundamental counting principle says take category A times category B times category however many I'm dealing with, and that's the number of possibilities. I say out to category N because it's however many categories you're dealing with, right? Permutation, NPR. This is N things arranged R at a time. Next to that one, if you want to put, order matters. What we're getting to the next page, I don't like that one because it just says, hey, press these buttons, is NCR, combination. In combination, order does not matter. And I'll say chosen R at a time. Okay, we're trying to shorthand an entire unit here, and I know that that's rough. That's also why I didn't expect to get through stats today, that it would take this whole time just to do probability. If you're in here, you're good, okay? You're either a good student or good at math or both. And all the perfectionists in the room cringe because they didn't get 100 in Algebra 2. Stop it. Okay. Y'all, C is supposed to be normal, B is good, A is a friggin' rock star. Not everyone can be captain of the team. All right, not everyone is perfect. And if you've been telling yourself that you have to be perfect, or your parents have been telling you that, it is unhealthy. You are literally setting yourself up to gaslight yourself for the rest of your life. Stop it.
You told me that in middle school, but like.
Okay, here's the cheat code. Combinatorics. I can either use NPR or NCR. I can use either one. Combinatorics. For combinatorics, I'm going to take all of these principles and I'm going to smash them together in a single problem. I'm going to take a bunch of NPRs times NPRs, or CRs, if order doesn't matter. And I'm going to use that subscript to denote that it's just whichever categories I'm dealing with. Okay. Whatever categories I'm dealing with, I'm going to keep multiplying together the permutations and combinations that tell me how many of those options I got. Right? Fundamental accounting principle. You multiply together the categories to get the total. I'm going to multiply the categories together to get my successful options. and then I'll divide it by my total number of things with my total number of things chosen. We'll do a couple practice problems like this, and you'll see it's actually pretty simple. It's just we've never seen it before. Okay? If you're going a little cross-eyed, okay, if you're like Gizmo from Gremlins right now, where your eyes are going, wee, that's okay. We're going to practice a few. Yep. Just realized I used a 1985 reference on a bunch of kids who were born this millennium. Okay, who's seen Gremlins? Original Gremlins.
I have like the toy. It's so gross.
It was in the same era. It's the whole like don't feed them after midnight, don't get them wet, otherwise they turn into the little green goblin things and they took over the town and all that. It was a metaphor for parenting because it started really cute and then they turned into goblins that ruined everyone's lives. No, it's just it gets more complicated and expensive and there's a lot of damage done. Here we go. Cool. Actually, okay.
Yeah, I just didn't part yet because I was ready to go.
All right. So where do we got room? Right where all the NCR stuff is. Oh, they actually have it. Good. I thought it was just press the buttons. Yay. Okay. A. We've got 7 seniors, 5 juniors, 4 sophomores on the PEP squad. You know, the kids who only know even numbers. Mr. Reinhardt says that we're going to choose 12 students out in the group to sell spirit buttons during lunch. How many ways can 12 students be chosen? How many ways can I choose 12 kids? So, y'all come back. I know that was my fault, right? If I say I am choosing 12 kids to sell this stuff, does the order in which you are chosen matter? Like, do they get different jobs? Or is it just 12 kids going to sell buttons? Okay. So how many ways can they be chosen is very simply just how many total do I have? Total kids. I got 16 to choose from, and because order does not matter, look above. You see how they got rid of half of the options? They got rid of the repeats. That's why combination is smaller. You get rid of the repeats because the order doesn't matter. So I'm going to say combination 12 kids. What you would have done back in Algebra 1 is you would have said 16 factorial over 12 factorial 4 factorial. R and n minus r. Okay? Just the formula up there. You would have done that in Algebra 1. We are just going to press the button. Okay? So how many ways can I choose 12 kids to go sell spirit buttons? I heard 18 something 20. Okay. Because order does not matter, so it's a combination, not a permutation. Part B is the actual combinatorics. Yep. Yeah, it is. If the students are randomly chosen, combinatorics is when I ask for a very specific outcome. What's the probability that out of all these kids, I specifically choose 4 seniors, 4 juniors, 4 sophomores? That's my outcome, and it's a very specific one. So, what are the categories I'm talking about? The different classes, right? So I'll ask, How many seniors do I have to choose from? Does the order they're being chosen matter? So I'll use combination. How many of them am I choosing? 4. That's category 1. I multiply it times category 2. Yep, 7 seniors. In category 2, I'm talking about juniors. How many juniors do I have to choose from? How many will I be choosing? 4. They said I'm specifically going to have 4 of each class. Times category 3, sophomores. How many sophomores do I have to choose from? How many will I choose? Common sense. If I have 4 to choose from and I'm going to choose 4, how many ways can that happen? Just once. So if I ever have NCN, it's just 1. This is the number of ways that I can randomly choose my seniors, randomly choose my juniors, randomly choose my sophomores. If I multiply that all together, that's the number of ways I can choose these 12 kids. Probability is successes over total. So I'll divide that by how many total kids do I have to choose from, and how many total am I choosing? That's how I make probability. Successes over total. Jam it all into the calculator. I strongly recommend parentheses.
Wait, okay, when I was trying to show you how old my calculator was, it doesn't have the shortcut because it only has 4 options for the shortcut. 7.
See, I know they have the alpha y equals, the fraction shortcuts, but I didn't know that they had a limited function shortcut.
And instead of selecting them by these buttons, like some calculators, I don't know if mine's the one that selects them by these buttons or if it selects them by these buttons, but I couldn't figure that out. I missed like I sat there during an entire math class, and I couldn't do it because I couldn't like figure out what button I was supposed to press. That one.
What's that? 7.
Math? What? Am I supposed to get a decimal point?
Yeah.
Oh.
Y'all, this is probability. Probability is the percent chance that it happens. What's the lowest percent chance that something happens? What's the highest percent chance that something happens? You should get a decimal between 0 and 1.
Give me a moment. I'm not so.
So, I set up fraction. Frank takes a while to, he's kind of laggy. 7, 8, choose 4. By alpha window. 8. I got 5 things we're choosing 4, right? Alpha window, 8. Got 4 things I'm choosing 4. Close my parentheses. Well, I got 16 kids. I am choosing 8. 12 of them. Okay. The difference between Algebra 1 and Algebra 2 is I first learned permutation combination by factorials versus now I'm on to combinatorics and I can set up the big ugly problems for very specific probability. Okay. Right below that, I hope you have, or just a blank space anywhere. I'm going to toss some stuff up here and let's see if we can figure it out.
What was the answer to that?
I
I got 9.6%.
I got 5 50-seconds or math, change to decimal, 9.6% chance. Okay. So
I believe in you too.
I'm ready.
I believe
There are.
we should need a different color. I'm gonna give up.
There,
200.
there are 200 juniors.
That's not our school.
Actually, we're not too far off. I think it's 180.
Yeah, 173.
170 something? Yeah. All right, fine. There are 170 juniors. I'm going to say there are.
You're bleeding.
There are.
I know.
Um,
Yours graduating.
30 French.
Why are you giving me enough of that?
There are 150.
That makes it quick. Then I'm gonna have to do with Ava. I love Ava. But she used to boss me around. She still does. Yeah. Exactly. It was kind of scary. And then she oh.
Like, we're putting this physically painful. Don't care.
Okay. There are 170 juniors in the class. We'll assume that there are 100 kids currently in math class. 30 of those are in French. 115 of them are in sports, but no one is in all three because life. I know this isn't true. I'm making crap up. Deal with it. Find the probability that a group chosen at random has exactly 5 math kids, 2 French kids, and 6 in sports.
Wait, so no one doubles up anything?
Yeah. Fine. Y'all gonna be that way?
why did we change it? I like it.
Because you complain.
I didn't complain.
Sammy, this is all your fault.
Y'all just do the problem. Just there are 3 different categories. Mandarin Chinese.
Sammy,
No.
I'm not the one that said that. I was confused.
Probability, so that's successes over.
I just want to see if you can set it up right. Look at the combinatorics. I'm pulling numbers out of an orifice. These are probably going to be a really, really small probability. Okay? You're looking for a very, very specific outcome.
Wait, is this... What's the chosen group? Like, what's the size?
Well, 5, 2, and 6.
Not really, because it's...
5, 2, wait, where did we get this? I'm so...
Okay, so we're going for, like, 13 million.
So how many total do I have to choose from? Oh, I was just making stuff up. There you go. I should have added the numbers together. Sorry. There. Because that didn't add up to 170.
No one overlaps, so you're just going...
No one overlaps. No one's doing more than one. Okay? When they do start to overlap, that's when you get into hypergeometric calculation. And real dorks will use hypergeometric calculators to do stuff like how many lands should I put in my magic deck. Yeah.
245. Yeah. How do you? I'm pretty sure I did this wrong, but how do you do the bottom part?
Flop all these numbers.
What do you mean flop them?
You have 100, you're choosing 5.
Oh, so dumb. What if I want to do it the other way?
Then it literally will tell you 0. Because you're saying I have 5 things to choose from, I want to choose 100. How many ways can that happen?
Like, it can't.
0.
But what if it could?
You're Chuck Norris?
No. What is the number? Oh, 2.
Well, it's just saying that these are all the keys. It doesn't really matter what order you.
There will be an arrangement word or phrase if it's a permutation. So they'll say something like, how many ways can I choose 5 smartest to dumbest? How many ways can I choose 2 shortest to tallest? It is combination. Yep. There will be some sort of arrangement word.
Oh wait, so 100.
Where you guys set yours up, right? 105, 32, 156.
I the hard part is figuring out combination.
Something Nora get it?
Maybe I see.
No, I'm not laughing.
It's not as low as I
Okay.
thought it would be.
It's not as low as we'd think it would be because my 5, 2, and 6 are roughly more proportional to the total amounts. When you're trying to say something like, all right, I'm going to choose 13 kids, what's the chance that 12 of them are in the Mandarin class? That's going to be super low because compared to the other totals, there's not that many of those kids. Okay? Combinatorics is it's a rough one if you haven't seen it before. I understand that most of us have not seen this before. Okay, so I'm going to assume that we can do the matrix stuff easy peasy. It's mental math. I am just going to have assignment tonight is just going to be about probability. Okay? It is just about probability. They might be simple where it's just counting principle, multiply together the categories. They might be simple like the answer is 7 factorial. They might ask for something ridiculously specific and you need combinatorics. Okay? There you go.